at the Chapter 5 test to kind of help you get started on your test review. All right, so the first few questions are asking about graphing when given factored form. So I'm going to talk you through this step. So the first thing that I'd like you to do is identify the zeros. There's an x term out in front by itself. That means your first zero is 0. Base we have is an x plus 6, and our zeros are always the opposite of our factors, so the next zero is negative 6. Negative 4, our last zero is positive 4. In my graph, and I'm going to put a point at 0, a point at negative 6, and a point at 4. The thing we're going to pay attention to is the multiplicity. The multiplicity of our 0 has to do with the exponent. If you don't see one, you can put a 1. So next to 0, I'm going to say that 0 has a multiplicity of 2. 6 has a multiplicity of 1. And 4 has a multiplicity of 4. We're going to pay attention to that in just a little bit. Okay, the second thing that we're going to talk about is the end behavior. When we look at the end behavior, or to determine the end behavior, we look at the lead term. So to find the lead term, we're going to take the front piece and all of our pieces that are being multiplied, and we're going to multiply them together, okay, including the exponents. So I'm going to highlight we have an x to the second, we have an x to the first, and we have an x to the fourth. X to the second, x to the first, times an x to the fourth. Together, I have 4, 5, 6, 7, x to the 7th. There's no number in front, you can put an imaginary 1 there. And since this one is positive, that tells me that this polynomial is going to end up. Since the exponent is odd, that means the end behaviors have to be different. It has to start down. Okay, so I can come here and say, okay, I know it's going to end up. And I know it's going to start down. So now we just have to determine what happens in the middle. And the next thing that I like to do, talk about where these zeros are going to bump and where they're going to cross. Okay, the polynomial will bump where it has an even multiplicity, where it has an odd. Okay, so if you look, multiplicity is even, right? 2 is even, then 0. The next one, the multiplicity is 1, which is odd. So negative 6. And the last number has a multiplicity of 4, which is even. So 4 is going to, okay, when I say bump and cross, cross means it's going to go on the other side of the x-axis. Bump means it has to stay on the same side. What you're going to be expected to do is find the y-intercept. Okay, to find the y-intercept, you're going to take every single x and replace it with 0. Like 0 to the second, times 0 plus 6 to the first, times 0 minus 4. Applying 0 times all this stuff, 0 times anything is just going to give me 0, which we already actually have plotted. I have to finish. So the first 0 I get to is negative 6. If I look, negative 6 is going to cross the x-axis, so it can go ahead and cross to the other side. At some point, it's got to get back to 0. Okay, and when I get to 0, it's either going to cross and come below, or it's going to bump and stay above. At 0, we said it's going to bump, so it's going to stay x-axis. Eventually, it's got to get to 4, and we're going to look again. Either 4 should cross and come below, or it's going to bump and stay above. And if you look, 4 also is going to bump. It's going to bump, and then it's going to continue up forever. Graph I'm looking for when I say sketch the graph polynomial of x to the second times x plus 6 times x minus 4 to the 4. Okay, so I'm going to look at the second one, but this time I'm going to go a little bit faster since we just did one. Zeros. So I have a -3, 1, and a 4, opposite of all these. So I'm going to go ahead and plot -3, +1. Okay, with that, again, I'll put my little 1 here and my 1 here. -3 has a multiplicity of 1. 1 has a multiplicity of 2. The multiplicity of 1. Odd multiplicities we said are going to cross. So at -3, I'm going to go ahead and put cross. 1 is going to, because it has an even multiplicity, it will let it be. And the last one again has an odd multiplicity, so the 4 is also going to cross. Okay, next we're going to look at the lead term. So I have an x to the first times an x to the second to the first. Together, and again, if you need to put an imaginary 1 out in front, you can. It tells me that this is going to end up. So I can go ahead and come here and make sure I know it's going to end up. The exponent is even. And even exponents mean that these two endings are going to have to match to be the same. So if it ends up, it also has to start up. So I can come here, make sure it's up and up. Okay, we already talked about where it's going to bump across. So the last thing that we need is the y-intercept. Okay, so everywhere we see an x, we're going to replace it with a 0. 3, 0 minus 1 to the second, 0 minus 4. And the 0 really isn't doing anything. 3 times -1 to the second times -4. 1 times -1 is just a +1. So 3 times 1 times -4 is -12. And since this time our y-intercept is not graphed, now here's -10, -11, -12 will be somewhere here. And I'm going to try my best to make it hit that point. Make sure this makes sense. At -3, we said it's going to cross. So it's going to come below the x-axis, get to -12, and then it can start to come back up. And it's going to come back up and get to 1. So let's look at 1 to bump, which means it can't come to the other side of the x-axis. It's going to bump and go below. It's going to get to 4. Okay, when we see 4, we say it should cross. So at 4, it can cross, and it's going to continue. Okay, and I am done graphing number 2. Okay, the next one that we're looking at asks us to write in standard form and then classify and name the polynomial based on end behavior. So my reminder, standard form has to have 2 things. And when I say standard form, the first thing, it has to be in order from the highest exponent to the, okay, the second thing you have to do is combine any like terms. So before we name, let's talk about standard form. So we'll start with number 3. Look, these exponents are not in order, so I'm going to pick out the highest one. Okay, the highest one is negative x to the fourth. So I'm going to write negative x to the fourth. I then see a positive 2x to the third. Positive 3x to the second. Negative 6x. And lastly, positive 12. Just to combine, I just had to take these exponents and put them in order: 4, 3, 2, 1, none. If you look at 4, we have 3, 2, 2, and then none. However, for 4, we have two x squared terms. I can rewrite x to the third, but 2x squared plus 3x squared is going to turn into 5x squared. And tack on the plus 10. The first part of the question, standard form, we are now done with. Which leads us to the second part, which is to classify or name it. When we name polynomials, we name based on two things. We name is based on the degree, and the second thing that we name is based on how many. I'll give you a chart to help you name these. If you need to go back and look at your notes, I believe we did this in 5.1. The first one, the degree is 4. Okay, the degree is 4 tells me that we have a second thing, how many terms? We have 1 piece, 2 piece, 3 piece, 4 piece, 5 pieces. 5 pieces just mean we're going to use the word polynomial. Okay, so we have a quartic. The next one, if we look at the degree, is 3. Degree is 3 tells me that I have a many. So we have 1 piece, 2 piece, 3 pieces. And 3 pieces, we call it a cubic trinomial. Okay, so there's the name part of this. The last part of this question asks us to describe its end behavior, which is kind of the same thing as what we did in our graphing problems. Clear out some space. When we talk about end behavior, we look at the lead term. The lead term is always the term in front. Okay, so when we talk about end behavior of the first one, we're only looking at negative. Since it's a negative, and if you want to put a 1, you can. Negative tells me it's going to end down. Look at the exponent. Even exponents mean the endings are going to be the same. So if it ends down, it also has to start down. So I'm looking for down and down. The lead term is x to the third. Again, if you want to put a 1 out in front, you can. This time it's positive, so it's going to end up. Is odd, so that these endings have to be different. So if it ends up, it has to start down. So I'm looking for down and up. All right, so the next question asks us to write a polynomial with the given zeros in standard form. Standard form, again, means multiplied out, combined like terms, in order from highest exponent to lowest exponent. I'm giving you 3 zeros. Okay, the way we write it in standard form is to take these zeros and then use them to write 3 factors. So I'm going to put x. Since we have 3 zeros, we should end with a cubic x to the third polynomial. Okay, the key to this problem is knowing that zeros and factors are opposites of each other. So here where I have a -2, I'm going to put a +2. Where I have a +1, I'm going to put a, where I have a +4, I'm going to put a -4. And once we do that, it's just a matter of multiplying this problem out. So we've actually got to multiply in 2 phases. Okay, the first thing I'm going to do is take these first 2 pieces and I'm going to FOIL them. FOIL them, I'm going to take x times x, which gives me x to the second. X times -1, which is -1x. 2 times x, which is 2x. 2 times -1, which is -2. If we combine like terms, we're going to, so I'm left with x to the second. Plus 2 is going to give us +1x minus 2. Put parentheses around those. And then I'm going to bring down the third piece, which was x minus 4. And we're going to multiply again. Okay, when I multiply again, I'm going to take x squared times x, which gives me x to the third. I'm going to take x squared times -4, which is -4x squared. I'm going to come to x. I'm going to multiply x times x, which is x to the second. -4, which is -4x. And then lastly, I have to do the same thing with -2. -2 times x, which is -2x. And -2 times -4, which is +8. Okay, the last phase of this is to actually combine any like terms. So I have y equals, I have an x to the third. I have -4x to the second plus 1x to the second gives me -3. I then have a -4x minus 2x, which gives me -6x. And then lastly, I can tack on the +8. I've got all my pieces in order. I've combined my like terms. So here's the polynomial in standard form given -2, 1, and 4. All right, so the next one, we're looking for zeros. For most of these, we're going to use factoring. Well, it's going to be faster than what we've done recently. The first problem that I gave you, however, is already in factored form. So all I'm looking for you to be able to identify is that zeros are opposites of the factors. Okay, so I'm going to start here. Anytime you have an x piece out in front without a plus or minus, you're going to use 0. Okay, the next thing I see is a +2, so I'm going to have a -2. The third one is a -5, so I'm going to use a +5. And the last one is a +10, so I'm going to use. Okay, the second part of this question asks for the multiplicity. Well, the multiplicity is just how many. The way you find it is to look at the degree or the exponent. So if you don't see one, I'm going to come put a 1. So 3x, since it's to the first power, has 0 has a multiplicity of 1. 2 is to the first power, so I have a multiplicity of 1. The 5, however, is to the third power, 3. X plus 10 is also to the first power, so again, I have a multiplicity of 1. Okay, so that's all I'm looking for in number 6. That we can do is number 7. 7, you're going to factor, but if you go back to, I think, maybe 5, 3, since it's x to the 4th and x squared, we are going to factor using higher powers. So I'm going to put my two sets of parentheses, but normally when we put an x, we're going to put an x to the second. Okay, we're looking for factors of c, so 16, 8, give us negative 8. Since this we're summing, the signs are going to be the same, and since it's negative, they're both going to be negative. So if we go through our list, 1 times 16, we get 17, not 8. Okay, 2 times 8 gives us 16, when we add together, we get 10. So that leads me to 4 times 4. See, when we add those together, we get 8. And since we want a negative 8, we're just going to make it negative 4 and negative 4. So I'm going to come put negative 4 and negative 4. If you look at just one of these pieces, we now have two pieces separated by subtraction, x squared and 4, that are both perfect squares. So we're now going to factor this a second time using difference of two squares. Squared is x. Since it's a difference, we're going to make one positive, one negative, and the square root of 4 is. Since it happens to be the same thing twice, we'll have it again. X plus 2 and x minus 2. To solve, just like the problem above, we're going to use opposites. So the opposite of positive 2 is negative 2. Okay, the opposite of negative 2 is positive 2. Again, the opposite of negative or positive 2 is negative 2. And the opposite of negative 2 is positive 2. Okay, however, we are not ever going to write. So the two answers that we found were 2 and negative 2. So those are the two that I'm looking for. Okay, since there are two of them, right, we have negative 2 twice, we say that negative 2 has a multiplicity of 2. 2 occurs twice. 2 also has a multiplicity of 2. What I'm looking for there. Okay, the next one that I'm looking at is number 8. Briefly glance through these three terms. It's not higher powers because we don't have even and half. Factor normally because it's not x squared and x. So the first thing that I'm always going to look for is there a GCF. And when I glance through, the first thing I notice is that they all have an x. If I keep looking, 2 goes into all of these. And everything, 2x. Okay, when I divide everything by 2x, I get 2x to the second minus x minus 1. And the 2x is just going to stay on the outside and we'll deal with it later. Okay, so now if you look, we have a term or a number in front that's not 1. We have a number in front, not 1, and we get down to x squared and x. The way we factor this is to do the slide divide bottoms up. So I'm going to take the 2, I'm going to slide it to the negative 1 to x squared minus x minus 2. We're then looking for things that multiply to give us negative 2, that subtract to give us negative 1. Well, the only things that multiply to give you 2 are 1 times 2. Subtract those, you do get 1. So we know we're going to use 1 or 2. Since it's a negative number, we want the bigger of the 1 and 2 to be negative. 2 and a positive 1. So when I factor this, I have x plus 1 x minus 2. Split the 2, we have to come back and divide. 2, we're going to divide by 2. Here, 2 minus 2 goes in evenly, and we're left with negative 1. If it doesn't go in evenly, the last step is the bottoms up. So the denominator of the fraction is going to come back and sit in front. And then we can kind of bring down the 2x and the equal 0. Okay, so here's what this tells us. X equals. We said anytime we have an x out in front without a plus or minus, my first answer is. Okay, we then said we're going to use the opposite. The opposite of positive 1 is 1. But since we're multiplying by 2 out in front, we're going to divide, and we're going to get, negative 1. And then we're going to divide by 2, so negative 1/2. And then lastly, the opposite of negative 1 is positive 1. Since each one of these pieces are an exponent of 1, they all have a multiplicity of 1. Okay, so that's what I'm looking at for that one. Which leads us to the last one. Ooh. Okay. Okay, the last one, again, we're using factoring. I have x to the third and x squared, so I can't use my higher powers. You look, there's not an x in everything, there's not a number in everything, so we can't use GCF. Is that there are 4 terms. When there are 4 terms, see if we can factor. Okay, factoring by grouping says we're going to take the first 2 pieces, so x to the third, and we're going to put parentheses around them. We're going to put a plus to group the second 2 pieces. So I have a negative 5x minus 10. We're then going to look for a GCF in each one of these pieces. So the first 2 pieces share an x squared. So I'm going to take the x squared out in front, and I'm left with an x plus 2. Pieces have a negative 5. So I'm going to divide by negative 5, and again, I'm left with x. This is what we want. When you factor by grouping, you should always get a matching pair. Okay, the x plus 2 are the matching set. Answer. And the 2 pieces that are left, the x squared minus 5, become my second answer. I use this x plus 2 to say that x equals negative 2. I have one answer. However, this x squared minus 5 still has an x squared, but since it's missing a middle term, I can set it equal to 0, and I can solve this using square roots. I'm going to add the 5. I'm then going to take the square root, and since 5 is not a perfect square, I get x equals the square root of 5. But remember, when you solve, anytime you solve square roots, you're always going to tack on a plus and minus. So I get 3 answers. Negative 2, positive square root of 5, negative square root of 5. Just occur one time. They all have a multiplicity of 1. That's what I'm looking at for number 9. Find the real or imaginary solutions to each polynomial. Again, I like to factor if at all possible. Although before we start, if we're going to factor, we have to get it equal to 0. Okay, the way we do that is we've got to take the 24 to the other side. When we move it across, we have to do that by subtracting. So we're left with x to the second, x, 4 is equal to 0. Okay, when I factor, I'm looking for factors of negative 24. Since it's negative, that subtract to give us negative 10. Okay, if we go subtract, we can deal with the signs later. So I'm going to start 1 times 24 gives me 24. When I subtract them, I get 23. So that's not what I'm looking for. Then maybe I try 2 times 12. Also gives me 24. This time when we subtract, we get 10. So either I can take 12 minus 2, which gives me 10, or I can take 2 minus 12, which gives me, and since I want a negative number, I want the bigger number to be negative, so I'm going to use 2, negative 12. So I have x plus 2, x minus 12. Once I get it factored, the answers are always the opposites. Tells me my first answer is negative 2, and the minus 12 tells me my second answer is positive 12. For 11, I'm going to try to use factoring, but this time we have a number out in front that is not 1. Whenever the number is not 1 and we have an x squared right in an x, we're going to start by sliding. So I'm going to slide the 4 to the 1, so I have x squared plus 4x. 1 times 4 is going to turn this into plus 4. And this time, since it's a plus 4, we're going to use factors of 4 that sum to give us 4. So we've got 1 times 4, but when I add them together, I get 5. This number I know is 2 times 2, and when I add those together, I do get 4. And since it's a positive 4 that we want, we can keep these two numbers positive. So I can now write x plus 2 and x plus 2. And we have to come back and divide. Since we slid the 4, we have to divide by 4. Okay, 2/4 is going to reduce to 1/2. And then we're going to go bottoms up. So I can take those 2's, put them out in front. So I have 2x plus 1 times 2x plus 1. That equals 0. So now, instead of positive 1 is negative 1. And since there's a time 2.5 in front, we're going to put, the answer is going to give us the same. So the way we account for that is we just say that it has a multiplicity of 2. And I'm done with 11. Okay, the next one asks us to divide using long division. So we're going to start by writing the problem. I'm going to write 1 divided by, we have an x to the third plus 7x squared plus 15x. Okay, first step of long division is to divide. It's a little bit different when we've got variables and not numbers, so I'm going to take x divided by, or divide it into x to the third. So x to the third divided by x is x to the second. I then take x to the second and I multiply it by the x plus 1 times x is x to the third, and x to the second times 1 is positive x to the second. We subtract. we subtract, it's going to change both signs. So x to the third minus x to the third is going to cancel. Turns into minus x squared, which is 6, x to the second. And then we bring down the next piece, which is 15x, and we repeat. So now we have x into 6x to the second. The second divided by x, 6x. I'm going to come put positive. We then multiply back by x plus 1 and distribute. So 6x times x is again 6x to the second. Times 1 is a positive 6x. When I subtract, I change both sides. Squares cancel. Minus 6x is going to be 9x. Last piece. I do it one more time. So 9x this time divided by x gives me 9. Multiply by the x plus 1. 9 times x is 9x. Times 1 is 9. Subtract, subtract. And this time it's going to cancel, cancel, which means my remainder is equal to 0. Oh, and I should have put this up here. Sorry, plus 9. When I get this 9, I should come put it up top. Remainder is 0, which means x plus 1 is a factor and goes in evenly. But the answer that I'm looking for is x to the second plus 6x. If it had a remainder, you would tack it on the outside. But since the remainder is 0, you don't have to worry. Ask to find if something is a factor. Okay, the way you tell if something is a factor is through division. Okay, and we know it's a factor is equal to 0. So here you can choose. You can either do what we just did and use long division, or you can use synthetic division, which is what's coming up next. Synthetic division. So I'll look at 13 and y'all can go try 14. Synthetic division is a little bit different because you're always going to use the opposite of the factor. 2, I'm going to use a positive 2. I'm then going to list the coefficients or all the numbers in front. If there's nothing there, put a 1. So I have a 1x to the third, a 1x squared, a negative 10x, a positive 8. Okay, first step is to always bring down the first term. So I'm going to bring down a 1. 2 times 1 is 2, and I add down. 1 plus 2 is 3. Then I'm going to repeat. 2 times 3 is 6. I get negative 4. Okay, 2 times negative 4 is negative 8. 0. Number of synthetic division is always the remainder. And for 13, since the remainder is 0, it goes in evenly. If it goes in evenly, then the answer is yes, it is a factor. Let's try 14. Synthetic division, so you can do that one. I will do 16. And the reason I'm going to do 16 is because I want you to notice we have x to the third, we have x to the second, but we're missing an x before we get to the negative 60. I do synthetic division here for number 16. I'm going to use the opposite of negative 2 again, which is positive 2, and I'm going to list the coefficients. So I have 5 and 8. But if it ever skips a 0, and then we have a negative 60. First step is to bring down the 5. 10. Okay, 10 plus 8 is 18. 2 times 18 is 36. 6 is 36. 2 times 36 is 2. I get 12. Let me make sure that's right. Yeah, 12. I get a remainder that is not 0. The way we write our answers when we do synthetic division is we take the degree that we started with x to the third. And you're going to subtract 1. So our problem is going to start with x second. So we have 5x to the second plus 36 with a remainder of 12. Okay, so what I'm looking for is 5x to the second plus 18x plus 36 with a remainder of the remainder theorem. When you divide a polynomial, the remainder is the same as evaluating. So for this next problem, let's to find p of -2. So you can plug in -2 and you can evaluate. But the remainder theorem says that we can use synthetic division and get the same result. Here is, since they don't give us an x, we don't use the opposite. So I'm going to come use -2. The coefficients. So I have 2, x to the third, 5x squared, 7x, -4. I'm going to start by bringing down the first term. So I have -2 times 2, which is -4. When I add down, -2 times 1 is -2. When I add down, I get 5 times 5 is -10. When I add down, I get -14. Remainder theorem, all we care about here is the remainder. So what it says is the remainder is if we were to plug in -2. So p of -2 is just -14. Or sorry, excuse me, list the possible rational roots. If you need to go back in your notes, is from the rational root theorem, which we did 0.5 thing that we did. When it comes to rational root theorem, I'll let y'all do 18. I'm going to walk you through 19. You care about the constant, and you care about the leading coefficient. In this case, the constant is -8. We don't really care about the negative because at the end of the day, we're going to use plus or minus in our answer anyway. The numbers that go into 8 evenly. So I've got 1. I've got 2 times 4 gives you 8, so 2 and 4. And then 8. These are all the numbers that go on the top of our fraction. And then I'm going to do the same thing with 3. So I've got 1 goes into 3 evenly. So these are all the numbers that will be at the bottom of my fraction. So I'll do the 1. If I take all of these and I put them over 1, they're all just going to reduce to whole numbers. Plus or minus 1, plus or minus 2, or plus or minus 8. I am then going to take the numbers 1, 2, 4, and 8. I'm going to put them all over 3. And this time the fraction won't reduce, so I've got now plus or minus 1/3, plus or minus 2/3, 4/3, and lastly plus or minus 8/3. Okay, so the rational root theorem says that these are all the possible rational roots. And when I say rational roots, that means all the roots that basically, for the context of this, don't have I or don't have square roots left in their answers. To take that rational root theorem, and we're actually going to try to find the rational roots. So again, I will look at 20. Ooh, actually, possibilities. So we're going to look at 1 goes into 6, 2 goes into 6, 3 goes into 6, 6 goes into 6. Numbers in front, 1, so we've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus. You then would use synthetic division to test possibilities. And here is where I messed up. I did not mean to give you a problem like this, but when you test all of these possibilities, remainder equal to 0. Sorry. Okay, so for number 20, there are no rational roots. The way you could solve it is by graphing. Okay, so that was my mistake. So stop 20, and I'm going to walk you through 21. Okay, 21, we're going to get our possibilities. Okay, we've got 1 goes into 4, 2 goes into 4, 4 goes into 4. And we're then going to take the 2, and I've got 1 and 2. These. If I put it over 1, I just get whole numbers, so plus or minus 1, plus or minus 2, plus or minus 4. I'm then going to take all these over 2. Add to this plus or minus 1/2. But if you notice, 2 over 2 is just going to become 1, and 4 over 2 is just going to become 2, which are already on our list. Choices. We're now going to use synthetic division to test these choices until we find one that works. Start by testing -1. And I'm going to list the coefficients. So I have a 2, a -5, a -4. I'm going to bring down the first term, and I get 2. 2 is -2, add down, get 5. -1 times 5 is -5, add down, I get -10. -10 is 10, add down, I get a remainder of 6. So unfortunately, this doesn't work, and I have to try another one. So maybe this time I try again, bring down the 2. 2 times 1 is 2, add to 7, I get 9. 9, add down, I get +4. 1 times 4 is 4, I add down, I get a remainder, 0. Okay, that's good. That tells us that 1 works. Okay, so my first answer, I'm going to come and write x equals 1, circle, because I know I at least have that. I'm then going to rewrite. So we said earlier we started with x to the third, so I'm going to end with x to the second. So I have a 2x to the second plus 9x plus 4. And we're going to see if we can factor. Okay, if we can factor, chances are we have rational roots. If we can't factor, you can always use the quadratic formula. Rational roots mean we have no I, or we have no square root. So if you get an I in your answer, don't use it. You get a square root in your answer. Don't use it. Again, since a is not 1, we're going to go through our process. The first step is to slide. So this becomes x to the second plus 9x plus 8. And factors of 8, since it's positive, we want them to sum to give us 9. So I've got 1 times 8. Okay, 2 times 4 gives us 6 when we add them together, but 1 times 8 gives us 9. So I've got 1. Since it's a positive 9, we're going to keep both positive. So I've got x plus 1 times x plus 8. With the 2, we have to divide back by 2. Okay, if it goes in evenly, then we're going to, so we've got x plus 4. If not, we're going to go bottoms up, so we get 2x plus 1. Okay, so now we're going to take those and use them to write our answers. Factors are always the opposite of my answers. So since I have a positive 1, I'm going to use a negative 1. And since I've got a 2 in front, we divide by 2. It's a negative 1/2. And the opposite of 4 is, okay, the last check is to make sure that all these numbers are on our list. So if you look, 1 is on our list, negative 1/2 is on our list, negative 4 is on our list. That tells us that we should feel pretty good about our answer. All right, so the next one has to do with the conjugate root theorem. Conjugate root theorem said that any imaginary or irrational numbers come in pairs. The first thing I'm going to do is I'm going to go through this list and I'm going to highlight everything that has an I. Okay, if it doesn't have an I or a square root, it doesn't have to come with a partner. But if it has an I or a square root, it must come with a pair. So if 1 minus I is a root, then its conjugate, or 1 plus I. Okay, the next one. 5 plus square root of 3. Since it's got a square root still, its conjugate, or 5 minus the square root of 3, must also be a root. Okay, if 2i is a root, then negative 2i. But again, the negative 1 doesn't have an imaginary number, or it's not irrational. Okay, the next one, 7i, tells me that negative 7i is a root. And negative 3i tells me that 3i is a root. Okay, so that's all I'm looking for. Go back to, I think, the same process that we used in number 5. Okay, so I'm going to set them both up and multiply one of them. Here, though, is they give us 5i, which tells us that negative 5i must also be there, even though I don't give it to you. Okay, so for 25, I've got the opposite, so x plus 3, x minus 5i, but you also have to add x plus 5i. Okay, you'll FOIL, and then you'll multiply by x plus 3. Through and finish that one, but I will go through 26 all the way through. Okay, so for 26, same thing. I give you that x minus 5i, or sorry, x I is a root, which tells you that even though I don't give it to you, 6 plus I must also be a root. Okay, so we're going to set this up as x, the opposite, opposite of 6 minus I, and then x the opposite of 6 plus I. What that's going to do is it's going to change all the signs. So when I distribute that negative through, I'm left with a negative 6 plus I, and then a negative 6 minus I. And we're now going to multiply all this out. So I'll try to color code this so y'all can see what's happening. Pieces by 3 pieces, you're going to start with the first. So I'm going to take x times x, second. And then x times negative 6, which is negative 6x. Negative I, which is negative xi. I'm then going to come do the same thing with the negative 6. So negative 6 times x is negative 6x. Times negative 6 is positive 36. And then negative 6 times negative I is negative I. I lastly have to come and repeat the process with the positive I. So I'm going to take I times x, which is positive xi, times negative 6, which is negative 6i. And then I, which is negative second. Okay, we're now going to look through and combine like terms just a little bit. So the first thing that I guess we can do, okay, so I have y equals, I'm starting with an x to the second. Now I have a negative 6x, which is negative 12x. I have a plus 36. Okay, but what's kind of cool about these imaginary roots is that we have a negative xi, which will cancel. And we have, oops, sorry, hold on, I might need to fix something real quick. Okay, sorry, I have an I times x, negative I. Sorry, okay, here's my mistake. If you go back to green, when I do negative 6 times negative I in green, negative 6 times negative I, that should be a I. And if it's a positive 6i, that helps us because these i's are going to cancel. Okay, now, again, we've done this a while, but in case you need it, I to the second is negative 1. 1 turns into a 1. So my final answer here is going to be x to the second minus 12x plus 37. I missed. Let me go back real quick. Oops. Sorry. Sorry, I skipped these, even though it's not difficult, but I just overlooked it. Okay, finding the number of roots, the number of roots is the highest degree. Okay, the highest exponent. With the highest exponent in the second one, it's kind of trying to trick you because they don't put the terms in order. but the piece with the highest exponent is negative 7x to the 6th. So for this first one, roots. And for the second one, they would be. And now we're ready to do the last couple. All right, so we're going to do 29. So I'm going to start there, 29. First thing I noticed there are 4 terms. So you really have 2 choices. You can try to factor, or we said if you can't factor, you can use guess and check all our possibilities until we find the ones that work. Okay, I'm going to use factor because what I noticed is there are 4 terms and maybe grouping works. So I'm going to take, okay, x to the third, 4x squared, plus 9x minus 36, set it equal to 0. First 2 pieces have a GCF of x squared. So I'm going to take the x squared out in front, and I'm left with an x minus 4. But the second 2 pieces have a 9. So I'm going to put the 9 out in front, and I'm left with x minus 4. Okay, at this point, we expect there to be a matching set. Matching set, the x minus 4, put it out in front, and then I have the x squared plus 9. The x minus 4 gives me one of my answers. Okay, my first answer is the opposite of negative 4, 4. So now I have this x squared plus 9 to deal with. And since there's no middle term, no b, I take x squared plus 9, set it equal to 0, and solve to find the rest of our answers. I have to subtract 9, and then take the square root. The square root of 9, we know is plus or minus 3. The root of negative 9, we're going to tack on an I. Okay, we said, well, we didn't say, but I'll say it now. Degree is 3, so we should have 3 answers. My first answer is 4. My second answer is 3i. There is negative 3i. Okay, so I'm done with that. Same thing, I noticed that there are 4 terms, so I'm going to start by seeing if we can group. 2x to the third minus 3x squared plus negative 18x minus 8. Okay, I've got an x squared and an x squared. And that will leave me with 2x minus 3. Notice I can take out a negative 2. And I get a 9x forward. So if you look right here, when we take out a matching, or GCF, we do not have a matching set. And if we do not have a matching set, then you cannot use grouping. Which means we're going to have to go to option 2, which is to guess and check. And when we guess and check, let's get our list of possibilities by looking at the factors of 8. So we've got 1, 2, 4, and 8. And then we've got 1 and 2. And those are going to go on the. So here are all my possibilities. Okay, plus or minus 1, plus or minus 2, 4, plus or minus 8. Then we're going to do plus or minus 1 over 2, 2 over 2, 4 over 2, and 8 over 2. 2 over 2 is going to reduce to 1. 4 over 2 will reduce to 2. And 8 over 2 will reduce to 4, which is already on my list. Here are my possibilities. We're then going to, so maybe I start by checking 1. And again, I list the coefficients. So I have 2, and negative 3, and negative 18, and a negative 8. Start by bringing down the first number, which is a 2. Then we multiply. 1 times 2 is 2. Add down. 1 times negative 1 is negative 1. Add down, negative 19. 1 times negative 19 is negative 19. Add down. We're not going to get 0. We try another one. Okay, this time, I'm going to try negative 2. Negative 18. Negative 8. Bring down the 2. 2 times negative 2, negative 4. Add down negative 7. And 14. Add down negative 4. Negative 2 times negative 4 is 8. Add down, we get a remainder of 0. Okay, that tells me that the negative 2 works. So my first answer, at this point, I like to see if I can now factor. And either we can factor, or you can use the quadratic formula to finish. Okay, so I have some space. X to the third in this problem. So we now have a 2x to the second minus 7x minus 4. Again, since the number in front is not 1, we're going to start by sliding. So this becomes x to the second and x minus 8. And we're looking for factors of negative 8 that subtract to give us 7. Well, I know 1 times 8 is 8, and when I subtract, okay, since the 7 is negative, we want the bigger number to be negative, so I'm going to use a positive 1 and a negative 8. I've got x plus 1, x minus 8. Since we slid the 2, we'll divide by 2. Okay, the 8, right, goes in evenly, or the 2 goes in evenly with the 8, so I've got x minus 4. Over here, since we have a fraction, we're going to go bottoms up, so I have 2x. And we now know the answers are the opposites. So we've got a negative 4, so I can come add. We've got a positive 1, so I can come add negative 1. But since we're multiplying by 2 here, we can come back and divide by 2. We can look and see, okay, the degree is 3, so I should have 3 answers. Right? 1, 2, 3. Done. Finally, on to the last one. So this time there are 5 terms, so I know I can't group. I don't have any powers, no way we can factor, so the only way to do this is to find the possibilities. So I'm going to list, okay, I've got 1 goes into 6, 2 goes into 6, 3 goes into 6, 6 goes into 6. Those are all my numbers on top. The good news is the number out in front is just 1. So when it comes to my possibilities, it's just plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus. Okay, because of time, we know that we're going to have to test these until we see which ones work. With one that I know works, so we're going to start with -2. Coefficients, I have 1, -1, -5, -6. And I'm going to bring down the first term. -2 times 1 is -2. Add down, I get -3. -2 times -3 is 6. Add down, I get 1. -2 times 1 is -2. Add down, I get -3. And -2 times -3 is 6, which gives me a remainder. So again, my first answer, -2, I know that works. What I like to do is see if I can factor. So this time, since we started with x to the 4th, I'm going to end with 1x to the, we have minus 3x squared plus 1x minus 3. And since there are 4 terms, before I keep guessing and checking, I'm going to see if I can factor by grouping. So I'm going to put parentheses around the first 2, parentheses around the second 2. The first 2 have x squared in common. So I'm going to factor out x squared with x minus 3. The next 2 have nothing in common, so I'm going to factor out a 1. Notice we do have a matching pair. So x minus 3 is my first factor, and x squared plus 1 is what's left. The second answer, the opposite of -3 is 3. So right now, if I'm going to have my list, I have -2. This last little piece has got an x squared but no middle term, so we said to solve that, we can set it to 0. I'm going to subtract 1. So x squared equals -1. And when I take the square root of -1, it's just plus or minus pi. So again, we said degree is 4. I should have 4 answers. I found -2, then I found 3. I can now add I. And -pi. Okay, and that concludes my review. All right, so that was, yeah, maybe not all, but most.